Have you ever wondered what actually happens to a human body and mind if you were to fall directly into a black hole? These are regions in space where gravity is so powerful that nothing can escape its pull, not even light, which is exactly why they appear perfectly dark to our telescopes. Scientists study these interiors because they represent the most extreme laboratory in nature, a place where the rules of physics are pushed to their breaking point. The story of a black hole begins with massive stars. For millions of years, these stars maintain a delicate balancing act. They produce immense energy through nuclear fusion, pushing outward, which fights against the crushing inward pull of their own gravity. Eventually, that nuclear fuel runs dry. The outward pressure completely stops, and gravity finally wins the intense battle. The star suddenly collapses under its own staggering weight. This triggers a supernova, a massive, violent explosion that blasts the outer layers of the star deep into space. If the core left behind is heavy enough, the collapse doesn't stop. It continues pulling inward until all that remaining mass compresses into a single point, so small and so intensely dense that it defies our everyday physics. A black hole is born. These stellar black holes are dozens of times heavier than our sun, but there are also supermassive variants, millions or billions of times heavier. If we look right at the center of our own Milky Way galaxy, we'll find a giant one called Sagittarius A star. Because these collapsed stellar tombs emit absolutely zero light, we can't observe their interiors from a distance. To truly understand them, we have to embark on a fascinating theoretical journey right to the very edge. As you approach a black hole, you aren't greeted by a quiet, empty void. Instead, you enter a violently swirling storm of stellar material. This visualization shows matter spiraling downward. Accelerating toward the center creates intense friction, superheating the gas to millions of degrees, causing it to emit powerful X-rays. By mapping this glowing gas with telescopes, astronomers can pinpoint the exact location of the invisible object inside. This glowing halo of doomed material is the universe's only warning sign. Once you slip past it, you reach the absolute point of no return. That boundary line is called the event horizon. It's the exact threshold where the gravitational pull becomes so strong that the velocity required to escape exceeds the speed of light. If a friend were watching from a safe distance, they would witness something bizarre as you approach this line. Instead of seeing you fall straight in, they would see you slow down. Eventually, you would appear to freeze completely, suspended in time right at the boundary. This strange optical illusion happens because intense gravity literally warps time. It's a direct consequence of Albert Einstein's theory of general relativity. But from your own internal perspective, time wouldn't seem to slow down at all. You would continue falling, feeling the seconds tick by normally as you crossed the threshold. Here is what physically happens next. The gravitational pull on your feet becomes exponentially stronger than the pull on your head. Scientists call this lethal process spaghettification because your body is stretched vertically and compressed horizontally into a long, incredibly thin shape. Crossing the event horizon severs your connection to the universe outside, as both the human form and the steady flow of time give way to the pull of the singularity. Once a black hole consumes its immediate surroundings and sits in the dark, does it remain there forever? Physicist Stephen Hawking proposed that they don't. He theorized that black holes actually leak a tiny amount of energy, slowly losing mass over time through a process now known as Hawking radiation. This evaporation is incredibly slow. For the largest black holes, fully dissolving back into the universe would take far longer than the universe itself has currently existed. Some physicists have also explored the idea that the center of a black hole could connect to a wormhole, acting as a tunnel through space and time. But while the math allows for it, there is absolutely zero physical evidence that such cosmic portals exist. Hawking's discovery revealed that black holes follow a defined life cycle, spanning from their violent birth to a slow, multi-billion-year decay. For nearly a century, all of this was confined to whiteboards and mathematical models, but in 2019, the Event Horizon Telescope team brought the theory firmly into reality. They synchronized radio observatories across the globe to capture the first ever direct image of a black hole. They photographed its dark shadow, perfectly silhouetted against a ring of superheated, glowing gas. That single image confirmed decades of complex, abstract calculations with hard visual proof. These silent giants push physics to its absolute breaking point, and every time we look closer, they bring us one step closer to understanding the true laws of reality.